This call is now being recorded.
Okay. So the next topic that we're going to do is called resistance and resistivity. So for the first one, just remember that we have Ohm's law. In Ohm's law states that current is directly proportional to voltage if temperature remains constant. Wait a second, kids. Now, basically, whenever you have something directly proportional, like you see here, so if you draw current and voltage graph, you would see a straight line like this, and which means voltage is directly proportional to current. And this graph that you see is only true for ohmic conductors, like that. So there's some ohmic conductors like a fixed resistor and a variable resistor. So fixed resistor basically looks like this. And the variable resistor looks like this. So the fixed resistor basically means that it has a fixed value of resistance, for example, like 100 ohms. And variable resistance means that it has a range of values of resistance that can be independently controlled. Like you see, variable resistors are everywhere. Like the one that you use to increase the speed of your fan, you turn it, that's also variable resistor. So you can write this down, and if you have any questions, do let me know. Okay. All right, kids. Done. Should I go forward, please? Okay. So the next thing we're going to do is the non-ohmic conductors, and the first one is the category of semi-conducting materials or semiconductors. Let's write that. Make it simple. So the first one is thermistor. Thermistor looks like this, and thermistor has a property that if temperature is high, if temperature is high, you have low resistance, and if temperature is low, then you have high resistance. This is the reason that there will be two kinds of graphs they're going to give you. You guys should remember that. So if they give you current versus temperature, then this graph would look something like this. Current would rapidly increase as the temperature increases. And if they give you resistance and temperature, then basically it would decrease like this. You guys need to remember that. It's inversely proportional, that's why. Sort of like that. Then you have the light dependent resistor, commonly known as LDR. It has this symbol. So at high light intensity, there is low resistance, and at low light intensity, like in darkness, it has high resistance. It works like that. So both of these need to remember thermistor can be used in fire alarms, and LDRs can be used in burglar alarms. So it can be used like this. You can write it down. Let me know if you have a question. Everything's clear, Furkan, Salma, Raza?
Yes.
Yes, sir.
Yes, sir.
Okay. Dani, Asma, Fatima, everything's clear? Very good. It's uh, it's not exponential. It's sort of inverse proportional, Salma. Because as the temperature would increase, the resistance would decrease, and it's sort of a diminishing return that at very high temperatures, like you cannot have 100% zero resistance. Still, it will be resistive, but even at high temperature, it still has some resistance. Okay, Salma. Same, same thing. Temperature is increasing, resistance is decreasing, so current will increase. Okay, you get it? Then the next is diodes. Diode is another semiconductor. Diode basically looks like this. So diodes basically only allow current if it passes like this. But then if the current is going in the opposite direction, like here, it does not allow current. So it only allows current to go in one direction. Now diode has a function called rectification. You will learn this more in detail in A2. But simply, you should remember that it is converting alternating current to direct current. And that's because diode only allows current in one, direction. Alternating had two directions, so it just cancels out the other one. Anyway, if you draw the graph of current and voltage of diode, the negative current here, negative voltage. So diode would only let the current pass quickly after like zero point 0.6 volts, and then it requires minimum of that, and then in the opposite direction it doesn't allow any current to pass. So this is the graph of a diode. This is the reason that it takes such a low energy to work, and we have LEDs that take up very less amount of energy or power to work, saves us cost. That's fine. Now then you have metallic metallic conductors. Now for metallic conductors, I just want to tell you kids that here they are also non-ohmic, by the way, although they're metals. When large current flows through them, it causes heating. Then, due to increase in temperature, the lattice vibrations increases. Then, this causes resistance to increase. All right, so this is how it works. Now, the thing is that in a metal wire, obviously, metal has a fixed structure like this. And when the current is going, it causes heating, this current, which causes these particles to start vibrating. Okay. And when they vibrate, it is difficult for the electrons to flow. So they go, from different directions. So the resistance increases. Although metal is a good conductor, but at high temperature it's very bad. So this is why if you use your phone for a long time, you might notice that your phone gets warmer. That is because current causes heating. So if you have a current and voltage graph like that, then this would show you something like this. Because the current, as it goes up, as you can see, as it goes up, there is a point where resistance is so high that doesn't let the current increase anymore. As it gets too hot, that's why. So you can write this down as well, and let me know if you have a question here.
Sir, why is the concept of metallic conductors just opposite to thermistor?
Thermistor is a semiconductor, and for semiconductors, they like, I'll tell you a bit about it, okay? In semiconductors, what happens is that you have three different layers. Every material has a conduction band, okay, from where conduction can happen. And then there is a forbidden gap where materials, where electrons cannot stay. And then they have valence band as well, valence. So in valence band, generally the electrons live, right? If you provide them enough energy, they can jump to conduction band and then start conducting. Do you get it? So if you
One
notice,
more time, please.
yes, there are three bands, okay? There's a valence band, there's a forbidden gap, and there is a conduction band, okay, in any material. So the electrons need to jump from valence band to the conduction band in order to conduct electricity. Is it clear? Now, this gap is not too big in semiconductors, so if you provide them any kind of energy, the electrons make the jump and they start conducting. Do you understand that?
So the energy in the gap is what is allowing electrons to pass through.
The energy that we provide that allows the electrons to jump from valence to conduction without They cannot stay in forbidden gap. Do you understand?
Yes, sir.
Now, if you notice, every semiconductor thermistor takes temperature, heat as the source of energy. Light dependent resistor takes light as the source of energy, and diode takes a little bit of voltage to do that. Is it clear?
Yes, sir.
Now, issue with metals is that metals have the conduction band and the valence band overlapping. They don't have forbidden band at all. Do you understand?
So,
That's why at low temperature they're so good conductors. So electrons can freely move. That's why we say they have sea of electrons because they can freely move from valence to conduction without jumping or requiring energy. But then if you give them a lot of like current, it causes heating. Now the particles within valence band start to vibrate, and when they vibrate they disturb the conduction band, and that's why the resistance increases. Do you understand?
yes, now I understand. Thank you.
There was a time this chapter was there in A2 physics, but now they've removed it. It still works anyway. Now,
Also, sir, what was the point of the graph you made for the diode?
point of the graph is that if it's going if the current is going in the positive direction of things, like it would conduct it really quickly, but then if it moves in the opposite direction, it doesn't let it conduct. No current, see, the opposite
Okay, sir.
direction.
Okay.
All right, please copy this. If you have any questions now, let me know. Okay, now kids, then we have resistivity. So let's write that. Resistivity is a measure of how resistive a particular material is. For example, you have a wire that has a cross sectional area, let's call this A, and then this conductor has a length as well, let's call this L. So you guys need to remember resistance is proportional to length, and resistance is inversely proportional to the cross sectional area, which means that longer the length, higher the resistance will be. And then greater the cross sectional area, smaller the resistance will be. Like that. Alright, kids.
Yes.
If you basically relate these together, so it will be length over area, you remove the proportionality, it basically becomes resistance equals to rho L over A. This rho is called resistivity. Its SI units are ohm meters. It is a unique value for each material, and also this is a scalar quantity. You guys need to remember that. All right. Now, unfortunately, we need to learn the resistivities of different materials as well, but that's not too hard. So you have to remember, like in the estimation questions, they can ask you this. So you have materials, you have resistivity, so in ohm meters, we're going to learn this. First of all, silver, copper, nichrome, aluminum, lead, mercury. Then we're going to learn about graphite. We're going to learn about uh, germanium. We're going to learn about silicon. And then comes the insulators like glass, quartz, etc. So all these that are metals, we have 10 raised to minus 8 in ohm meters. So this is pretty easy that way. You only need to learn the order of magnitude. You don't need to learn anything else. Graphite is a carbon material, so it's 10 raised to minus 6. It can conduct. These are semiconductor. Germanium has 1, and this is 10 raised to 3. Glass is very high. 12, 10 raised to 12, 10 raised to 16. So all these 10 raised to minus 8 ones are metals. So anytime you read about the metal, you should remember this power. This is carbon conductor. These are semiconductors, and these are insulators. So you can remember these values, and this is how it's going to be.
Sir, what is the last one?
Quartz. Quartz. All right.
Yes, thank you.
Very good. Now, whenever you're doing these questions, what happens is that you will find two different cross-sectional areas. So keep in mind that area of cross-section of a wire would either be a circle or a rectangle. It could be a strip of wire as well, okay? So in any case like this, just remember with respect to radius it will be pi r square. With respect to diameter it will be pi by 4 d square, and it has length and width. So the area of strip will always be length into width. So it's simple. You can write it down. So generally you'll find a lot of ratio questions in this one. And usually what we want is we want to make sure that we solve these ratios with the proper method, otherwise, and also make sure you have like allotted a bit of at least 4 or 5 minutes for them to be there. There are, you can always, use the ratios directly, but sometimes you may get the wrong answer. We don't want that. All right, kids. Should I go forward, please?
Yes.
Sure, sir.
Now, the first type of question we're going to do for this one, that's right. Question one. Let's say an iron wire has a length 8.0 meters and diameter 0.50 millimeters. Then wire has a resistance R. That says a second wire has a length of 2 meters and diameter 1.0 millimeter. They are made from same material. All right. Now they say, what is the resistance of second wire in terms of R? All right. So this is the question. Now remember this important point that whenever they say same material or same metal or something like that, It means same resistivity because resistivity is a unique value, right? So that's why. Now, whenever you get these ratio questions, I would highly recommend that you write the things in the formula. Rho R, rho L, A, and because there is a diameter, we're following this formula R equals rho L upon A. We're gonna look at wire 1, we're gonna look at wire 2, and then we're gonna compare the values. Let's see. So wire 1 has a resistance R, take resistivity as rho, length as 8.0 meters, and the diameter was 0.50 millimeters. We want to find resistance 2. Rho is rho because there's same material. Length is 2 and the diameter is 1. Now I just want to tell you this important part. If you look at the formula of area, you might realize that area is pi by 4d square. If pi by 4 is a constant value, so pi is dependent on d square. So if I say the area of the second wire is A, then because the diameter of the first wire is half of a half of the diameter of first is half of the second one, which means that now the area will be a quarter. Do you guys understand that?
Yes.
Because it's a function of square. All right, so you can remember that, or you can, if you want, you can also find it out. It's all right. Because area is proportional to d square, you can say, okay, if I square 1, it will still be 1. If I square 0.5, it will be 0.25. So it's up to you. It's up to you, it doesn't matter. And pi by 4 is irrelevant because it will cancel out in a ratio anyway. Once you have filled this table, it will only take like few seconds to do. And then what you can do is you can simply start solving this way. So I'm going to say wire 1. So in wire 1, it will be R times rho and length over area, which is 0.25, right? And then in wire 2, R equals to rho times 2.0 and 1, like that. Once you have the equations made, you want to find the ratio, just divide both equations. Now, if you divide the both equations, it will be like R1 over R2, which is essentially equal to R over R2, and then just write their formulas. Rho 8.0 divided by 0.25, put this sign and write the other one as well. Now, there's a reason why I put this sign, because when I take when I convert it to multiply, I have to take reciprocals. 1.00 divided by rho times 2.0. Cancel stuff out now. As you can see, rho will be cancelled with rho, and 1 has no importance. 2, 1, 4. So 4 divided by 0.25 is basically something like, wait, let me move this a bit. I don't have much space left. Move it to top like that. Okay, now I do. So as you can see now, R over R2 becomes 16, which means that R2 will be equal to R over 16, and that should be your answer. Do you guys understand that?
Yes.
So this is one way to solve these ones. It's pretty simple. If you just make this table, then you don't get to make any mistake in the question because you've written down everything and made the ratios out. You can do it directly as well, like thinking, okay, um, length is like 4 times, and then area is also 4 times. So if you have 4 times length, you have 4 times resistance, and then if you have a quarter length, then you have another 4 times resistance, so it's going to be 16. But then it also creates sometimes you get it wrong, and you don't want to lose that bar. If you have any questions, please let me know. Okay. Now the next kids. Oh my god. The next one is question number 2. In question number 2, a pencil is used to draw a line of length 30 centimeter and width 1.2 millimeter. So resistance is 2.0, sorry, resistivity is 2.0 into 10 is to minus 5 ohm meter, and resistance is 40 kilo ohms. This says what is the thickness of the line. Now, from this question, I should understand that it's not a cross section, it's not something of a circular cross section. We're dealing with a rectangular cross section here. And naturally, what they're really trying to ask you is that this line has a length of 30 centimeter. You also have the thickness here, sorry, width of 1.2 millimeter, and you want to find this thickness T. Okay. Now again, I will try to create the table. So I will put down every value that I have. Resistance is 40,000 ohms. Resistivity is 2.0 times 10 raised to minus 5 ohm meter. Length is 30 centimeter. Area is just A because I don't know what this area is. Okay, I want to find that. Now simply use the equation. Write R equals to rho L over A. A will be rho L upon R. So rho is in the SI units, so we're going to keep it that way. Resistance length we're going to change, so it will be 0.30 meters. And then we're going to divide this by the resistance, which is also in SI units. I think you should get an answer of 1.50 times 10 raised to minus 10 meters squared. And the area will be width times thickness. So width will be 1.50 times 10 raised to our, sorry, that would be the area. 1.50 times 10 raised to minus 10. The width is 1.2 times 10 raised to minus 3 because it's 1.2 millimeters and we want to find this thickness T. So then the thickness should come out to be 1.25 times 10 raised to minus 8 meters, like that. So both cross sections can be given. Sometimes they will ask you with two wires. You should know that's a ratio question. If they don't, then it's a direct question. You still use the same formula with the right formula for the area. All right. So it's not that hard. All right, kids. Any questions now?
No.
Okay. Pretty good then. So we're done here with this particular part. I think we are only now left with DC circuits and nuclear physics. So probably we might be able to finish within the next week. All right, kids.
Yes. Thank you, sir.
Have a nice day then.
You too.
Bye.